Alright, in this video we will show you how to deploy a Qumulo scale-out NAS cluster in AWS. Here's what we cover in this video. First of all, we'll talk briefly about what Qumulo is. There are a couple of other videos that describe that Qumulo is a scale-out NAS system and how you can deploy it and how the architecture looks like. We cover the infrastructure landscape in AWS into which we deploy the cluster. We deploy it through a CloudFormation template, so that means we will have a brief look of how the CloudFormation template looks like, so that you know what's happening or that you understand what's happening when we use the CFT to deploy a Qumulo cluster. It simplifies very much the deployments. It's a couple of clicks, so you should have a brief understanding what CFT is. And then we use it to deploy a cluster, and I show you how it works. Finally, we will create an SMB share and an FS share, and we mount these shares on a Windows system and a Linux system accordingly. So very brief, what is Qumulo? Qumulo is a scale-out NAS cluster. It supports the standard NAS protocols SMB, NFS, FTP, and HTTP. There are file system services provided in AWS as well as other clouds, but they are somehow very limited in terms of functionality, in terms of enterprise features, in terms of size, in terms of number of files that you can support, and they are also very expensive. With Qumulo, you can deploy a cluster with this CloudFormation templates in a couple of minutes. It ranges from 1.2 terabyte to multiple petabytes. You can scale as large as you want, almost. And here's how the architecture looks like at a high level. Qumulo not only works in the cloud, it also works on premise. It's typically deployed on x86 servers, which have internal drives to store the data. We have a network that's needed to connect all the nodes to each other for fast communication to the nodes for data exchange. We run a stripped-down version of Ubuntu Linux, currently 18.04, long-time support version. And then we run our Qumulo core file system on top of it. How does a Qumulo instance look like in AWS? Well, each server node contains a Qumulo AMI, the Amazon Machine Image. You need to select and set the instance type. You need to have at least one network interface. You need to have at least one IP address. We recommend having more, but that's a different story. A defined number of EBS volumes that you don't need to pick and choose manually, so we can set everything up with the CloudFormation template automatically. And also we set up the security group if you wanted to have at least the ports open that are required for the cluster to be able to communicate to clients and to the other nodes as well. Here's how the whole landscape in AWS looks like once we have deployed the Qumulo cluster and several other components like Windows clients, Linux clients, the Active Directory server, and some more components that are needed to use the Qumulo cluster as a scale-out file system. Don't worry that this looks quite complicated. We will go step by step and look quickly at each individual component that's listed here in the picture. Everything that's within the red dotted line here, that's the Qumulo cluster, and that will be deployed by the CloudFormation template. Let's go and look how that looks like step by step. So here's the overall starting point. You have the administrator connected to the internet, and we have also Qumulo Home, where we later send on telemetry data from our cluster. The first thing you would decide in which region you want to deploy your VPC. Then you would create a VPC if you don't have one already. Most likely you will have everything deployed within or for your company, but for the purpose of the demo, we just look step by step. So then you would create an internet gateway for your VPC so that the components can reach the internet, for example, for updates, and also you will be able to, as the administrator, to access the components within the VPC. Then for some components that have IP version 6 addresses and that want to access the internet from within the VPC, you need an egress-only internet gateway. And then you would pick and choose the zone in which you want to deploy your components. And you would deploy a public subnet for at least a bastion host to which you can connect from the outside world. But in our case, we have some more servers installed in this public subnet. For each subnet, you would create or modify your network access control list. The default is allow every traffic inbound and outbound, which is obviously not a good idea. So this is the first line of defense for you. We would create a NAT gateway, which we need to use later for components that have IP version 4 addresses and sit in a private subnet. We would need to create a routing table that has at least a route to the internet, and that points to the internet gateway, obviously. We would create a private subnet in which we want to deploy the Qumulo cluster. Also here we would create network access control list for traffic that we would allow or deny. We would create a routing table that has at least 2 routes. The first route would be for IP version 4 to the internet. That would be the target for that route would be the NAT gateway, because that sits in a public subnet and can access the internet. And for the IP version 6 traffic, that would be the egress only gateway. So we would create a security group. That's, if you will, a kind of a firewall for every individual server that you deploy. Then we would create our Windows Active Directory server and configure it with the domain that we want to use. And so that would be the starting point to be able to connect into the public subnet and access the Active Directory server and configure it. Also from here, we will later then jump to our components on our private subnet. We could deploy some Windows clients in that subnet. We could deploy some Linux clients in this subnet. Yes, and finally, we would deploy the whole Qumulo cluster at once. And everything that's deployed by the CloudFormation template will include the security group that is predefined but can definitely be extended. The security group will contain all filters or rules that allow the cluster to communicate via SMB, FTP, and NFS and so forth. Then finally, if we have the cluster installed, there is the routing table already set up to the NAT gateway, and through the NAT gateway, the cluster could send telemetry data back home, so that Qumulo has all the telemetry data to be able to help in case of issues for remote monitoring. Yes, and then we are ready, and we can then use the scale-out NAS system to deploy or to use SMB, NFS, and FTP protocols from the client's perspective. Let's have a closer look to the CloudFormation template now, which is being used to deploy the Qumulo cluster in the private subnet. The CFT itself can be downloaded from the AWS Marketplace. So let's see how it works. We go to the AWS Marketplace. And here you can search for Qumulo. And here are all the different deployment versions of Qumulo clusters that you can pick and choose. Every capacity that is shown here is the node capacity, and you can deploy different number of nodes as you need them. So let's pick and choose a small one for the demo purpose here. It's an all-flash instance. If you scroll down, we want to see the CloudFormation template. Here is for every cluster, you see View CloudFormation template. Click on it. And here you already have a visualization of what the CloudFormation template is deploying. That is the EC2 instances, the EBS volumes, as well as the security group and networking. So let's download the template, store it to a name that makes sense. The ending shall be template. Click Save. And then let's open it. So here's the CloudFormation template. And without giving you a detailed training on CloudFormation template, it might be useful for you to browse through it to see what is being defined. I will quickly do that and just give you an indication of what we do here so that when you use it, you understand what's happening in the background. Here is a mapping that maps the different regions to an AMI ID. That's an Amazon Machine Image ID. Every AMI has an ID. And here are different sections in this JSON file. It starts from metadata, where configurations such as the instance type, the key names, the VPC and the subnet ID, the cluster names defined. And then here is a parameter section as well. You see here there's an output section that outputs later on the node numbers as well as the private IP addresses. Here is a link to the management UI later on that is being displayed in the output section as well. Here is a definition, as you can see it, of the different instance types that you can pick and choose from later on. Here's the definition of the standard instance that is being recommended by the vendor, the subnet ID, the VPC ID, and so forth. And then you see a longer section where all the EBS volumes are defined, and we strongly suggest not to change this because if you change the storage layout, your cluster will not work. Then going forward, you have the network interfaces here. You see again storage definitions with size and block device base and so forth and so forth. I will scroll down. It repeats for every node, and this template has 4 nodes, so there's a lot of similar configuration details here for every node. If you decide you want to create a new security group like the CloudFormation templates, here are all the ports and target addresses that you need. It's pretty open to the world, so it might not what you need specifically, but we'll review that later on. Alright, that was a quick run through the CloudFormation template so that you get a rough idea what is configured here, and there is something that defines the infrastructure as code. Okay, so now let's use the template to deploy the cluster. I'm going to my AWS console, and in that to my running instances. And here you can see I have already deployed a Linux host in the public subnet and a Windows host in the public subnet as well. That same thing is being used as the Active Directory server. Now I'm opening a different window. Go again to my AWS console, but this time I'm going to CloudFormation templates, because this section I'll be using to create my stack, and a stack is a collection of infrastructure components, servers, network, storage that makes a stack. In the upper section I can select a template to use that is ready. This is the case here. I could use a template to use it and modify it accordingly so that it fits my needs, or I can use the template designer. Then here I'm saying I'm using the template that is ready. I can specify either a S3 bucket where it sits, so the complete URL, or I can say I'll upload my template. I pick and choose to upload my template. I've stored it here on my disk. I've downloaded it earlier from the marketplace. AWS automatically creates a S3 link for you. Going forward, you could use that to deploy your template as well. I click on Next. Now I specify some details for the stack. First, I'm creating a stack name. Let's call it Qumulo demo. Then here is a section that you may remember from the CloudFormation template where we are being asked for certain parameters such as the instance type. For the purpose of this demo, I pick and choose a small one. My my SSH key pair that I want to use to access the nodes later on. My VPC ID, that's important. I pick and choose the Qumulo demo Stefan, which I've created earlier. Then my subnet. You can see here we have a couple of subnets in that VPC, but I've created two specific ones, one private subnet and one public subnet. We use the private subnet because that's the one where we want to build our cluster in. And finally, I can give it a cluster name, and I will call it Qumulo cluster. All right. Now, best practices, always for all infrastructure components, provide some tags. For example, a name tag, you could provide it a purpose tag. That's called, in this case, could be demo. It could also be, the value could be development, production, customer, whatever. I create an additional tag that's called department. That could be very useful, for example, for billing. So system engineering, that's the department I work for. Okay. Then I click next. And here you can review all the settings that you made. Here's the template. Here's all the parameters that you provided, the tags, and that's good for now. And I can now say create stack. And then we can see here such a stack already exists. What a shame. So I have to edit the stack name and I'm calling it Qumulo demo 1. Click next, review, and create stack. Here we go. So you can see here I have created a similar stack earlier for creation of this video, so that's the reason why I needed to rename it. Now here is the stack that's being created. You have to watch the output section later on, because here we will see when the stack is created with some additional information like the IP addresses of all nodes and a temporary admin password to be able to access it the first time. For now, I'm switching back to my EC2 management console. I will click refresh and you will see here the stack has already been created. However, there are 3 nodes that you can see right now, and they are in state initializing. And if I click refresh, I will most likely see the 4th node, yes, also initially. I will pause the video for a minute and then the cluster should be ready. Alright, so not even after 2 minutes the whole cluster has been deployed. I'll go back quickly to the stack page, and here you can see the output. In the output section of the stack you can see the private IP addresses of the cluster. Just mark one of it or copy one of it into your clipboard, and then also copy the temporary password into your clipboard that is now being used to access the cluster. So let's go and change the screen. I will jump to my Active Directory server to which I have RDP'd. So here is the instance, and here I will use the browser now to access my management UI from the Qumulo cluster. Here you go. You will see this risk warning message. That's because we have used a self-signed certificate. So click Advanced and say accept the risk and continue. And here we are. That's the web UI of the cluster. So I use the username admin. That's the default root user or administrative user. I copy and paste the password, temporary password. Alright, here is the dashboard of the cluster, which shows you some useful information. We'll not go through it because the purpose of this video is just to cover the installation. Here we are. Everything is done. You could go to network configuration and check if the IP addresses are similar to what we have seen in the EC2 console, and of course they are. You can see here the rest of the network configurations that's automatically set by the CloudFormation template. The next thing we want to do is to join the Active Directory domain with this cluster, and that's also a very simple one-time task. So we go to Cluster, Active Directory, and here you just put in the domain name. So that's Qumulo.local. That has been configured in the AD server earlier. User. In that case, I've created my own user. But remember, this user has to have domain admin privileges within the Active Directory. Okay, so the NetBIOS domain name is typically, you can leave that blank, but it's typically just the first part of the domain name. And then I would highly recommend to click Use Active Directory for POSIX attributes. Yes, this will make sure, from my perspective, it's very important that Active Directory will be used also to store Unix credentials for the users. That means UID, group ID, home directory, and so forth. So these attributes are being defined in RFC 2307, and this makes sure that you have a unique and consistent view of users from the Windows side over SMB as well as the Linux side over NFS. This is very important. So I click now Join, and that's it. The next thing I want to do is to create a share that we can then mount on the Windows server, and for that I just go to Sharing and click on SMB shares. And here you see the SMB shares that have already been created. To create a new one, just click Create Share. Here's the Create Share page, and this is straightforward. I will give it the file system path. Let's say I will create a share that's called Stefan. I tell the cluster to create the new directory if it's not already existing. I give it the share name and a description. This is the home directory. Alright. I can decide whether I want to enable access-based enumeration, yes or no. I can ask to require encryption over the wire. And here I finally set the permissions for this share. I will definitely add myself to the permissions. So pick my user, and I would allow read, write, as well as change permissions. And then say create share. As you can see here, the share has now been created, and we can use it to mount and map this share to a Windows drive. So go to Network, Map Network Drive, pick and choose a drive letter, and then mount the share. You could pick and choose one of the cluster addresses or a DNS name, whatever. Say finish, and here we go. Here's now the share that we have just created, mounted to a Windows drive, and we have given it the permissions to read, write, so that we can even delete files here. You can see that works perfectly. Finally, I'm going to create an NFS export and mount that as well to a Linux host. So go to Sharing, NFS Exports, Create. I give it the file system path. Let me pick and choose just the same thing. Export path is also Stefan, description, home directory for Stefan. Here I could restrict to a certain amount of IP addresses that allowed to mount a share. I will not do that at the moment. I could also provide ranges. See the examples here. That's quite practical in certain environments for NFS 3. I could pick and choose some user mappings, which I don't do. They are mapped very securely per default, read only no. And so that was it. I'm clicking create, and here I got my export. Now going to my Linux client, I've opened a terminal session. I will log in into my Linux client in the subnet. Here I'm in. Here you can see I have used the private key that I have earlier created when I was creating the virtual machine. -LEC2 user is the default username for AMIs from AWS, and here's the IP address, the IP version 6 address of the Linux host. Alright, so let me clear that up. I've created the share. Let me now mount the share. Some best practices for mounting shares. There are some certain parameters which are optimal for performance. They are also documented in our knowledge base. I'll put the link down in the description section, and let me mount the share. Here you go. See that? Here the share is mounted. Let me go into it. And here you can see even the file that I have put in earlier on the Windows side. Finally, let's quickly recap what we did in this video. We explained the VPC landscape with a public and a private subnet. We explored briefly the CloudFormation template that we downloaded from the Qumulo listing in the AWS Marketplace. We have deployed our Qumulo cluster in the private subnet using the CloudFormation template. We joined the cluster to the Windows Active Directory domain. We created a Windows share and mounted that on a Windows client. And finally, we created an NFS export and mounted that on a Linux client. That was it. Thank you very much for watching.